Let's understand how to find factorial of a number through recursion. This is the recursive program to find the factorial of 3. And this is the visual representation of the call stack. One-sided open and one-sided closed. Now, let's evaluate the code line by line. First, the main function is called by the operating system. Therefore, the activation record of the main function goes inside the call stack. Now what's next? Inside the main function, within the printf, fact3 is called. This means fact function is called with value 3, which is passed as an actual argument to the parameter n. As the fact function is called, the activation record of the fact function with the local variable n goes inside the call stack on top of the main function's activation record. Notice that the value of n is 3 in the activation record of the current call of the fact function. Now, we are within fact of 3. As n equals 3, the base case condition is not satisfied. Therefore, the recursive case will be executed. In the recursive case, n is multiplied to fact of n-1. But we don't know the value of fact of n-1 yet. Therefore, we need to resolve fact of n-1 first before evaluating the entire expression. So, let's call fact of n-1, which is equal to fact of 2. As fact of 2 is called, the activation record of fact of 2 goes inside the stack on top of the activation record of fact of 3. Notice that the activation record of fact of 3 is not deleted yet because fact of 3 has not completed the execution yet. Remember, we left the evaluation of the expression n times fact of n-1 because we need to resolve fact of n-1 first. This is the reason why the activation record of fact of 2 is placed above the activation record of fact of 3. Now, we are within fact of 2. Again, the base case is not satisfied, and hence the recursive case will be executed. The value of the expression n times fact of n-1 can only be obtained after resolving fact of n-1. So, let's call fact of n-1, which is same as calling fact of 1 because in this call, the value of n is 2. Let's push the activation record of fact of 1 inside the call stack on top of the activation record of fact of 2. Now, we are within fact of 1. This means n is equal to 1. This time the base condition is satisfied, and hence value 1 will be returned to the caller of fact of 1, which is fact of 2. Therefore, at this moment, the activation record of fact of 1 is deleted from the stack, and hence the new top of the stack is fact of 2. As the new top of the stack is fact of 2, we are within fact of 2 with n equals 2. The place where we left off is fact of n-1 within the recursive case. Fact of n-1 will be replaced by the return value of fact of 1, which is 1. Therefore, the expression becomes n times 1, which is equal to 2 times 1, which is equal to 2. So, the entire recursive statement becomes return 2. The value 2 will be returned to the caller of fact of 2, which is fact of 3. The activation record of fact of 2 is deleted at this moment, and the activation record of fact of 3 is the new top of the stack. Now, we are within fact of 3. This time the recursive expression becomes 3 times 2, which is equal to 6. Hence the entire statement is return 6. Value 6 will be returned to the caller of fact of 3 and according to the call stack. Below the activation record of fact of 3 is the activation record of the main function. So, at this moment the activation record of fact of 3 is deleted, and the control shifts to the main function. We are now within the printf function where fact of 3 is replaced by the value 6, which is the factorial of 3. After this, 0 is returned to the operating system, and the activation record of the main function is deleted. Now, we can observe, the call stack is empty. As the printf function has received value 6, the final output is 6. So, this is how the factorial of n is calculated using recursion.